Hello students, very good morning. Today we will discuss the determination of ground state term symbols for SPD configurations, and this is very important topic for various kind of exams, and we will expect one question from this topic. Right. So here first of all we will discuss how to determine the term symbol for various configuration. So here you can see student. So here we have for electron revolve around the nucleus and electron revolve around on its own axis. So generally the electron has two types of spin motion student. One is spin motion and the second one is orbital motion. The spin motion is due to the revolve around on its own axis, and the orbital motion is due to around the revolving around the nucleus, right? So revolving around on its own axis, generally the electron can generate the spin angular momentum, and so the revolving around the nucleus, then it generates the orbital angular momentum. So here you can see student. So this is for a single electron system student. This is for a single electron system, and this one is for a many electron systems. So this is for a single electron system, for one electron system, and this is for multi-electron system. Here so we have different orbits are there, so the electrons are revolving around the nucleus, right? So here the motion of the spin angular momentum and orbital angular momentum, generally the atom behave like a small magnet, right? So here how to calculate the spin angular momentum for a single electron system. So generally for one electron system, so we can denote as S1 student. For multiple electron systems, so generally we can denote as S1, S2, S3, S4, so on. Okay. For orbital angular momentum, already we know very well about the means the moving electron revolving around the nucleus, and it generates the orbital angular momentum. For one electron system, generally the orbital angular momentum we can denote as L1. For many electron system, we can denote as L1, L2, L3, L4, so on. Okay. So J is the resultant angular momentum. So means it is the sum of spin angular momentum and orbital angular momentum. Generally, we can call it as a LS coupling scheme, or we can call it as a Russell-Saunders coupling scheme also, student. And so generally we can denote as a term, means we can denote as a letter, that is a capital J. The J is the resultant angular momentum. So how to find out the J values? Here it is the combination of resultant orbital angular momentum and resultant spin angular momentum, that is capital L plus S, comma L plus S minus 1, comma L plus S minus 2, and so on L minus S, right? So how to represent a term symbol, that is very important. So generally the term symbol, it is the atomic term symbol, so that is we can represent as 2 into S plus 1 L J. So J is the subscript and 2s plus 1 is the superscript. So this is a spin multiplicity. 2s plus 1 is a multiplicity. 2s1 is a multiplicity. Okay. So it's depend upon the number of electrons of a given configuration. So generally the L value is known as it is we can call it as a term. L value is term, and J is nothing but it is resultant angular momentum. Okay, right? It is depend upon L comma S values. Okay, if how to determine a term value. So here if L value is equal to 0, then the term is capital S. If L value is 1, the term symbol is capital P. If L value is 2, the term symbol is capital D. If L value is 3, the term symbol is capital F. If L value is 4, the term symbol is capital G. So these term symbols are very important. So the next examples, clear students? So please remember, so these L values student, the term symbols, right? So here you can see the first we will move on how to determine step by how to determine a term symbol. So we will discuss step by step process. The first we will do determine resultant spin angular momentum. Okay, So already we know very well, students. So generally the spin angular momentum is possible for the spinning of electron around on its own axis, right? For for a single electron system, student, we can denote as S1, student. For many electron system, we can denote as S1, S2, S3, so on. So here you can see, student. So this here we have taken an example, that is for P2 configuration, student. So here the two electrons are there. So this is a Px and Py configuration. Okay. So where, so two electrons in their orbital, one electron from Px orbital, another electron from Py orbital. So therefore here it is a multi-electron system. So for S1 for individual electron 1 by 2 and S2 for another individual electron 1 by 2. So therefore here we will get the spin angular, total spin angular momentum, that is capital S, that is equal to S1 plus S2 comma S1 plus S2 minus 1 comma so on S1 minus S2, right? So we will substitute the spin value, student, that is 1 by 2 plus 1 by 2 plus 1 by 2 comma plus 1 by 2 plus 1 by 2 minus 1, so on. So here plus 1 by 2 plus 1 by 2, that means 1, and then 1 by 2 minus 1 by 2, that is equal to 0. So the possible resultant spin angular momentum for sp2 configuration, student, that is 1 comma 0. So this is the way to determine the resultant spin angular momentum for different configuration. So the second one is determine the resultant orbital angular momentum, that is OAM. So here we are taking the example as P2 configuration of P2 configuration here. So this is, you can see, student, this is P2 configuration. So Px, Py, Pz. So this is 1, 2. There is no electron. So this is plus 1, 0, minus 1 we will write, student. So this is L1, student. L1, that is equal to 1 and L2 is equal to 1. So therefore here we are going to determine the resultant angular momentum, not ground state term symbol for this particular case. So generally we are going to determine the various terms will comes out for this configuration, but which is ground state term symbol we will discuss next example, right? Here you can see L1 is equal to 1 and L2 is equal to 1, and so here you can see L1 plus L2, students. So these are, we can determine for very vectorial configuration, student. So L1 plus L2, that is equal to 1 plus 1, that is equal to 2, 1 plus 1 minus 1, that is equal to 2 minus 1, and 1 minus 1, that is equal to 0. So therefore the possible term symbol, right? Please remember, so this is not a ground state term symbol, student. The possible term symbol for P2 configuration, that is very, very important. Here the possible term symbol, here you can see, that is 2, the term symbol is D, 1, the term symbol is P, and the 0, the term symbol is K. So these are the possible term symbol for P2 configuration. But what is the ground state term symbol? We will discuss. Clear, student? So this is the determination of resultant angular momentum, orbital angular momentum, and resultant spin angular momentum, right? So next we will move to the determine the total angular momentum, that means J value. So J is nothing but, student, this is here L plus S to L minus S, student. So that is very, very important. So generally remember, student, the L plus S for more than half filled configuration. So that is the more than half filled configuration. So L minus S is the less than half filled configuration. That is very, very important, student. For example, here we have P1, P5, P1, P5. So you can calculate for P1 for less than half filled. For P5 is more than half filled. Okay, clear. So P5 for more than half filled. For example, here we have D1. So D1 for J value is, you can take L minus S. For D9 configuration, you can take L plus S configuration. So it is more than half filled. It is less than half filled configuration. So that is the parameter for the consideration of L plus S and L minus S, right? Please remember, L minus S is the less than half filled and L plus is the more than half filled configuration. Clear? Right. So here I am taking one example, that is carbon atom, student. The electronic configuration is 1s2, 2s2, 2p2. But generally here the representation of a term symbol, student. So we will focus only the outer electronic configuration. Generally we will consider for 2p2 configuration, not for 1s2 and 2s2, student. So just you will consider 2p2 configuration only. That is the very important parameter, right? So here this is a 2 electron student, that is px and py student. So here we are taking the magnetic quantum number values for p orbital, that is +1 0 -1. So +1 0. So here we will get the capital L value student, that is the sum of L1 plus S2 student. L1 is equal to 1 and L2 is equal to 0 student. So therefore capital L is equal to, so here we are going to determine the ground state term symbol, that is very important student. So therefore capital L, that is the resultant orbital angular momentum, L1 is equal to 1 student, L2 is equal to 0, you can substitute. You will get 1 plus 0, that is equal to 1, or 1 minus 0, that is equal to also 1. So therefore here the ground state term symbol for 2p2 configuration, that is 1 only. Okay. If L value is equal to 1 student, the term symbol is capital P, that is very important. So yeah, then we will move to the S value student, that is the resultant spin angular momentum. We have two electron, so S1 is equal to 1 by 2 student, S2 is equal to 1 by 2. So therefore you can take 1 by 2, 1 by 2, 1 by 2 plus 1 by 2, that is equal to 1. So on 1 by 2 minus 1 by 2. So therefore the resultant spin angular momentum is also 1. So therefore L value is equal to 1 and S value is equal to 1. L value is equal to 1, S value. So therefore here we will move to the J value. So therefore L plus S means 1 plus 1, 1 plus 1 minus 1, 1 minus 1. So therefore the resultant angular momentum are 2 comma 1 comma 0, right? So here what is the term symbol student? The P is the term symbol. So therefore if the P is the term symbol means, then we will, what is the spin multiplicity student? 2 into 1 plus 1, that is equal to 3. So 3 is the spin multiplicity. So therefore the possibility J value is 2 1 0, right? So here the three possible term symbols are there, 3p2, 3p1, 3p0, but here we will focus the term symbol with the lowest J value is the ground state term symbol for P2 configuration. So this is the L plus S value. This is the maximum more than half filled, but here we will consider only less than half filled. So therefore for P2 configuration student, the 3p0 is the ground state term symbol, that is very important, right? So 3p2 for P4 configuration, 3p2 for P4 configuration means more than half filled. So because Pn and P to the power of 6 minus n are gives the similar number of microstates and similar term symbols only. Clear students? So this is the way to calculate, to determine the term symbol for various configuration, right? So next we will move to the, we will do some example student. I will start with S1 configuration. So that is very important student. Here you can see, here I am calculating S1 configuration student. Clear? So this S orbital has only one electron student. So generally we know very well the L value for S orbital always is equal to 0. Clear student? So therefore capital L is equal to L1, that is equal to 0 student. So therefore the term symbol is capital S. That's it, right? So then here we have only one electron, that means S is equal to 1 by 2 student. So therefore 1 by 2 plus 0 is equal to 1 by 2. So therefore the spin multiplicity 2 into S plus 1 student, that is equal to 2 into 1 by 2 plus 1, that is equal to 2 to get cancelled student. The spin multiplicity value is 2. So therefore here the term symbol is 2s. The term symbol is 2s. Clear student? The term symbol is 2s, right? So next we will do some examples of P configuration student. We will do some example. I'll change the color, right? So here I'll calculate for P1 configuration. So P1 and P1 configuration student. Here this is P orbital, Px, Py, Pz. So here we have only one electron student. So this is plus 1, 0, minus 1. So this is Px, Py, Pz student. Okay. So therefore L is equal to L1, that is equal to 1. So therefore the term symbol is capital P. So S is equal to, we have only one electron student. So therefore spin multiplicity 2 into S plus 1, that is equal to 2. So therefore the term symbol for P1 configuration is 2p, and here you can calculate the J value also, student. It is less than half here. L value is 1 and S value is 1 by 2. So therefore 1 minus 1 by 2. 1 minus 1 by 2 means nothing but 1 by 2 only. Okay. So therefore for P1 configuration, the term symbol is 2P1 by 2, right? So it is similar to P5 configuration, student. So the term symbol is same P only, but the J value is 1 plus 1 by 2, that means 3 by 2, right? So similarly, student, we can calculate 2p configuration, P2 configuration, student. For P2 configuration, the term symbol is 3p0, and for P4 configuration has a similar, that is 3p2, right? Next, for P3 configuration, student, we will do for P3 configuration, so the term symbol is 4 into. So this is the way to determine the term symbol of various configuration, right? So next we will do in the case of D configuration, student. Here I am taking for D configuration, student. For D1 configuration I am taking for D1, student. So here just you will write, so always you can take this format, student. So plus 1 plus here, so dxy divided like this. So this is plus 2 plus 1 0 minus 1 minus. So it is a very simple to get term symbol, student. So we have only one electron, so L is equal to L1, student, that is equal to 2. So 2 means the term symbol is capital D. That's it. It's very simple, right? So then here S value is equal to 1 by 2, student. So therefore here you can see 2 into 1 by 2, that is the spin multiplicity, student, that is equal to 1 by 2. So therefore the spin multiplicity, right? So the term symbol is D term, the spin multiplicity is 2, and the, so here you can see, student, so that is equal to J value. Here we will consider only less than affiliate configuration, student. So that is equal to 2 minus 1 by 2, student. So that is equal to 2 to 3 by 2. Clear, right? So it is similar to D9 configuration, student. So generally the term is capital D, and so 2 plus 1 by 2, student. So 2 plus 1 by 2 means nothing but so 5 by 2. Clear? So this is the term symbol of D, right? Next, for D2 configuration, student. So generally for D2 configuration, so generally we will take one more electron over here. So the term symbol is capital F for D2 configuration. The spin multiplicity is half plus half 1. So that means 2 into 1 plus 1, that is equal to spin multiplicity is 3, and the J value is so L value is 3, students. So 3 minus 1, that is equal to 2, right? So this is D2 configuration. For a D8 configuration, the term symbol is same, student. So that is equal to 3F4, right? Next, for D3 configuration, student. So for a D3 configuration, student, that is 3 by 2. So means 3 by 2 means nothing but, student, 3 into 3 by 2 plus 1, that is equal to spin multiplicity is 4, and so L value is also, so that is plus 2 plus 1 0. So means nothing but that is equal to also the the term symbol is F only. So L value is equal to 3 only. So therefore here that is equal to F. So and here we will calculate the J value for minimum electron, that is equal to for D3 system, student, that is equal to the J value is 3 by 2 only. Okay, right? So 3 by 2, right? Next, so D3 is similar to D7 configuration, student, that is equal to 4F, student. So that is equal to, so means nothing but so for a D7 configuration 3 plus 3 by 2, so that gives 9 by 2, right? Next, D4 configuration, student. So D4 configuration, the term symbol is so D4 configuration means nothing but 4 halves. So means 2 into 2 into 2 plus 1. So means the term the spin multiplicity is 5, and so the term value, the term symbol is capital D, and the J value is equal to 2 minus 2, student, that is equal to 5D0. For D6 configuration, so the spin multiplicity is the same, and the term is D L2 plus 2, that is equal to 5D4, right? So next, so we will move to the D5 configuration, student. So D5 configuration. So D5 configuration here. So 2 into 5 by 2. So means the spin multiplicity is 6 and the L value is equal to 0 student. Then the term symbol is 0 and the L value is the J value is 5 by 2. So this is the way to determine the term symbols for various S comma P comma D student. So just you practice it and you will get the term symbols is very quickly, right? So right student, we are here we have term, some rules are there. If the configuration will give the same number of multiplicities of a ground state term symbol, how to choose which is the ground state term symbol, and if the spin multiplicities are same, the term symbol is different, so how to choose the which is the ground state term symbol, we will discuss. Rules are one by one student here. So the rule number one we will discuss today. Right, so the rules we will discuss. The rule number one is the lowest energy term will be one with the highest multiplicity. So that means the maximum number of electrons. Here you can see student, we have different terms for the one configuration, that is 2p, 1p, 3p student. So which of the term is the ground state? So right here, what is the concept student? The highest spin multiplicity is the ground state. So 2p, 1p, 3p, here the 3 is the maximum number. So therefore the maximum spin multiplicity is the ground state term. So that is the rule number 1, right? So next we will move to the rule number 2 student. If there are more than one terms, if the more than one term with same spin multiplicity, the multiplicity are same, but okay, so here we have more than one term symbol. So how to determine the ground state? Here you can see 2p, 2d. The spin multiplicities are same. In the above cases, the term symbols are same, but spin multiplicities are different. But here in this case, the spin multiplicities are same, but the terms are different, right? So here the maximum L value is the ground state term symbol, right? So here the maximum L value. So L value for D is 2, L value for P is 1. So therefore the maximum L value is the ground state term. So that is the concept. Then we will move to the next rule, that is the rule number 3. For levels with equivalent spin, means spin angular momentum and angular momentum. Here we have two rules. One is the lowest level is that with minimum J value. So means nothing but less than upfield student. So that is the J is equal to here, that is L minus S. For here, for more than upfield configuration, you will consider J value is equal to L plus S. So this is the way to determine the configurations of ground state term symbol by using these formula student, these rules. So these rules was proposed by Hund scientist student, clear. So these rules are which helps to determine the ground state term symbol for various configurations, clear student, right? Right, next we will move to the summary of the topic student, right? So the summary means already we have discussed, that is for S1 2s, S2 S0 1s term symbol, for P1 P5 2p, P2 P4 3p, P3 4s, P6 P0 1s, D1 D9 2d, D2 D8 3f, D3 D7 4f, D4 D6 5d, D5 6s, for D10 1s, right? So this is the summary of the topic student. I hope it helps to determine the configurations of various configurations of the term symbols. It helps to student. It helps you student. So please practice and you will determine the term symbols very quickly. Thank you student.